This lecture provides a full, unified model of exchange rate determination that is both flexible enough to investigate permanent policy changes as well as to provide exchange rate implications for choice of exchange rate regimes. Our last lecture developed the asset model, and we used that to see how spot exchange rates change in response to temporary shocks or policy changes. We are now ready to look at how these rates change when the shocks or policies are permanent. A few key things to keep in mind are the following. When the shock is permanent, it affects expectations, as people know that the effect is here for the long run. As a result of the impact on expectations, future values, including the long-run exchange rate, are also affected. Along with any other short-run impacts on the spot rate, whatever effect is transmitted to the future rate also affects the spot rate, since the spot rate is determined as well by the future rate in the asset model. We will therefore proceed by unifying the monetary model of long-run exchange rates with the asset model of spot exchange rates to fully capture the impacts of any permanent policies or shocks. The asset model is based on UIP holding in the foreign exchange market. The monetary model is based on PPP holding along with long-run equilibrium in the money market. Consider as an illustration that the Federal Reserve decides to expand money supply permanently. How does this policy affect the spot exchange rate between the United States and some other country, say Japan? We have to think about this systematically. First, there is a direct impact today in the money market. The increase in money supply increases real money supply and causes the nominal interest rate to fall. So that puts an upward pressure on the spot rate. Second, the permanence of the policy affects the monetary model, which says that an increase in US money supply will cause the price level to rise in the money market in the long run, and via PPP will cause the future exchange rate to depreciate. This feeds back into the asset model, as people expect the future dollar-yen rate to depreciate. So the spot rate comes under further pressure to depreciate due to the increase in the future exchange rate. We thus have a very sharp depreciation in the dollar-yen exchange rate, resulting from the lower interest rates that result today and the expected depreciation in the future exchange rate. These are all depicted in the graphs on this slide. Again, we have the US foreign exchange market hooked up to the US money market. The initial equilibrium situation is given by the black curves in both markets. The effect of the permanent money supply increase by the Fed causes the real money supply to shift out to the right in the US money market, and the red vertical line indicates the new real money supply level. The result is that the nominal interest rate falls to I star. This translates to the US foreign exchange market as a reduction in the rate of return on dollar assets, the red line in the foreign exchange market. However, the permanence of the policy affects the future exchange rate, as explained earlier, and in this case it causes a right shift in the dollar rate of return on the yen asset curve as the future exchange rate rises. This is shown by the new red dollar rate of return on the yen asset curve. The result is a combination of depreciation pressures that cause the dollar-yen exchange rate today to depreciate sharply, as indicated by the red exchange rate. Now comes the fun part. To see why the monetary and asset models are consistent, let us walk through a process where we seemingly move from today gradually into the long run and see how the two models become consistent with a practical reality. So given the situation we have today, from the permanent policy where the spot rate depreciated considerably, as we transition to the long run, we observe the following. Prices that were sticky or fixed start to become flexible, and so they start to respond to the money supply increase by rising. This has the effect of reducing real money supply, which starts to return back to its original level in order to clear the money market in the long run. As real money supply returns, so also does the nominal interest rate adjust back to its previous level. This causes the exchange rate to fall, but not by so much, so that it still is higher than its previous level. So by the time we arrive at the long run, real money supply has not changed from its pre-policy level, and neither has the nominal interest rate, but we have a smaller net depreciation of the exchange rate. Recall, from the monetary model in the long run, money supply increases only result in price level increases, and the real level does not change. Similarly, in the long run, the nominal interest rate is only influenced by changes in expected inflation, and that is only brought about by money supply growth changes, and that has not happened, so it remains unchanged. Finally, in the long run, a money supply increase results in a depreciation of the exchange rate via PPP, and that's what we observe. We depict this transition on this slide. Pay close attention to the arrows. We assume the starting point is after the policy today, so we are at the red equilibrium values. As we transition to the long run, real money supply returns as the price level now rises from P1 to P2. This in turn causes the US nominal interest rate to rise from I double star and it approaches I star. In the long run, we are back to the initial level of real money supply, only at a higher money supply and price levels. We are back to the initial interest rate at I star. However, the exchange rate is still higher than the pre-policy level, even though it appreciated a little through the transition phase. So the net effect in the long run, as predicted by the monetary model, is the exchange rate does depreciate. Let us look at another illustration, now involving a permanent increase by the Fed in the growth rate of money supply. We have here a 3% permanent increase in the money supply growth rate. We further assume that output growth and the interest rates are constant in the long run. So how does this affect the current dollar-yen spot rate? First, since the level of money supply today has not changed, there is no change in the US money market in the short run. However, this is a permanent policy change and it affects the growth rate of money supply, so this will generate inflationary expectations via the dynamic quantity theory. The 3% increase in money supply growth will bring about a 3% increase in inflationary expectations. This will in turn, via the Fisher effect, bring about a 3% increase in the long-run nominal interest rate. So in the long run, the real money demand will fall in the money market, and to restore equilibrium, the price level will have to rise. If the US price level rises, then via PPP in the monetary model, the dollar-yen exchange rate will also rise. So the future exchange rate rises. This, however, means that even though there is no change in the US money market today, the foreign exchange market will be affected as the dollar rate of return on yen assets will increase due to the increase in the future exchange rate. As predicted by the asset model, the spot rate will therefore increase today in order to restore equilibrium, and as such the dollar will depreciate today against the yen. We can see the graphical depiction of this policy as shown on this slide. The permanent increase in US money supply growth rate does not affect the US money market. However, it affects the US foreign exchange market as the dollar rate of return on the yen asset curve shifts out to the right. This is indicated by the new red curve. The spot dollar-yen rate therefore depreciates today as depicted. As we did previously for the level change policy, we can transition from the short-run outcome to the long run to show that the two models remain consistent in their predictions. So starting out from the short-run outcome, we know that the nominal interest rate was not affected by the policy in the short run, yet we know that it increased in the long run. This happens because the policy announcement generates expectations of inflation, and this will lead in the long run to an increase in the nominal interest rate via the Fisher effect, and a resulting increase in the price level as real money supply falls to match up with real money demand in the money market. So there will be pressure on prices to start rising as we transition to the long run. Note, however, that the higher US interest rate should suggest that in the foreign exchange market, the dollar-yen exchange rate should appreciate. And it actually does. Only that it does not appreciate enough so that the net effect from the policy is still as the monetary model predicts, a depreciation from the pre-policy level. This is again depicted on this slide. Starting out with the short-run outcomes given by the red variables and curves, we have the US money market and foreign exchange markets depicted in their transition and future stages at the same time. As we transition to the long run, the nominal interest rate rises from I star to I double star to be consistent with the long run effect of the policy in raising the interest rates via the Fisher effect. This, as shown, causes the dollar-yen rate to appreciate, but it still ends up higher than the pre-policy level, thus being consistent with the monetary model's prediction that the dollar-yen rate in the future depreciates from the Fed policy that increased the growth rate of US money supply. One of the observed characteristics of floating exchange rates in practice is the volatility in their movements. A theoretical explanation for this is found in the concept of exchange rate overshooting. This happens when the short-run response of the exchange rate to some disturbance is greater than its long-run response. We have already seen this displayed in our discussion of the transition to the long run from the two policy effects. We saw that in the short run the exchange rate increased sharply and then appreciated a little by the time we got to the long run. This overshooting is the result of nominal rigidity, as the stickiness of prices causes the exchange rate to react excessively, but as prices ultimately become flexible, the exchange rate returns back to its proper reaction. In other words, if prices were fully flexible in the short run, we would observe less volatility in the foreign exchange markets. I have depicted this phenomenon again on this slide, on the right panel. Here we see that as the US interest rates fall, and if coupled with an increase in the future exchange rate, they both cause the dollar-yen exchange rate to rise considerably. Then as the US interest rate returns back to its previous level, there is a small appreciation that follows. The net effect, though, is still a depreciation in the exchange rate. We can use time paths to show the effect of a policy as we transition through time, somewhat analogous to our discussion on transitioning to the long run. But now we do that for different key variables. Let us consider the case where the US money supply was increased permanently. On this slide, I show the outcomes for money supply and nominal interest rates in the US. The time of the policy change happens at time t0. So we see that an increase in the money supply shifts the line up at time 0 from M1 to M2, and the level of money supply remains at M2 going into the future. Corresponding to this, the interest rate is at I1 before the policy, but at time t0 after the policy, it falls to I2, but then starts to rise over time back to its previous level, which it gets to in the long run. Next, we see that prior to time t0, the price level is at some level P1. At t0, it is still sticky, but then over time it starts to rise as prices become flexible. In the long run, they are fully flexible and the price level has risen to P2. Finally, we see the dollar-yen exchange rate. Before t0, it's at the level indicated by the black rate. At time t0, it shoots up to the red rate. Then over time it falls to the blue rate. Note that the blue rate still lies above the black rate, and this demonstrates the overshooting phenomenon. The analysis of exchange rate theory that we have both developed and walked through have assumed implicitly flexible regimes, where these rates were allowed to adjust freely. It's however important to note that these theories do have implications not just for floating regimes, but for fixed or pegged rate regimes. Remember, in many cases, operating under a fixed exchange rate regime does not mean there is no exchange rate, but rather that the country implementing it takes steps to ensure that market forces or shocks do not move the exchange rate from a predetermined level or range. Our preceding analysis, however, tells us clearly that assuming output is exogenously determined, a country with a hard peg ends up losing monetary policy autonomy in both the short run and long run. We demonstrate this next. Let us suppose that Saudi Arabia has chosen to peg their currency to the US dollar at the rate of 3.7 reals to the dollar. So the real dollar rate is 3.7. Note that I'm quoting this indirectly. Can the Saudi Monetary Authority use monetary policy to stabilize their economy once they're under this peg? The answer is no, both in the short run and in the long run. We see that if this peg is credible, then it means that the expected depreciation of the real dollar rate is zero under a hard peg. This means that by the UIP condition, the Saudi interest rate must equal the US interest rate. So in the short run, the money market equilibrium in Saudi Arabia must have money supply equal money demand, where money demand is given by an exogenously determined output, as well as the US interest rate given the peg. Since the price level is fixed by assumption of price stickiness, then only one level of money supply is consistent with this money demand. The Saudi Monetary Agency cannot alter the money supply to any other level than the single one that is consistent with these variables that are not under their control. Similarly, in the long run, since UIP still holds and the peg is still in place, the long run interest rate in Saudi Arabia must still be equal to the US interest rate. Now, by PPP and with the exchange rate fixed, Saudi Arabia's price level is determined as a fixed multiple of the US price level. This therefore means that in the long run, the equilibrium in the money market where money supply equals money demand, has money supply equal to variables outside the control of Saudi Arabia. Its interest rate and price levels are determined by US interest rates and price levels. The long-run output is determined by its resources and productive capabilities. So again, Saudi Arabia has lost the ability to change its level of money supply for any other reasons other than to have it be consistent with the exogenously determined level of money demand. A generalization of this outcome is found by a very important result in international finance known as the Trilemma. To understand it, first let us consider three very desirable policy goals that countries would like to pursue in global trade and finance relations. They are a fixed exchange rate, international capital mobility, and monetary autonomy. Each of these are desirable because respectively they facilitate stability in trade and investment, promote efficient risk sharing with greater economic integration, and they allow a country to stabilize its economy along the business cycle. The Trilemma tells us that it is impossible for any country to achieve all three policy objectives simultaneously, as mathematically it is impossible. Attempts to meet all three will lead to crisis, as has happened many times in countries across the world. The implications that follow, therefore, are that countries have to choose two of the three, at most, and live with the fact that the third will not be achieved. That is, if a country will operate under a fixed exchange rate regime and pursue full international capital mobility, then it must give up monetary autonomy. If it will operate a fixed exchange rate and still want to have flexibility to utilize monetary policy unilaterally, then it will have to impose capital controls, since arbitrage will result in the form of capital flight out of its country. Finally, if a country will allow for international capital mobility and monetary autonomy, then it cannot operate a fixed exchange rate regime, and its currency must float. We now summarize what we have learned from this lecture. The unified model combines UIP and PPP to provide a plausible model of exchange rate determination. The plausibility is found by its consistency across the two models in determining exchange rates, as well as by its providing an explanation for the observed volatility in exchange rates through exchange rate overshooting that features in the model. We have also shown that the pursuit of policy objectives by countries in a world of trade and finance flows is constrained by the trilemma, and so choices have to be made, with implied sacrifices. It's instructive to note that many of the exchange rate crises that have occurred have in some sense been linked to a failure to adhere to the reality of the trilemma. We are now done with the formal coverage on exchange rate theory. Take the quiz associated with this lecture and get ready to listen to the next lecture, which begins our coverage on open economy macroeconomics.